how do we translate the sounds of the universe into science? Well, first we need to make sure our instruments are tuned in and ready to collect data. We've heard the chirps of hundreds of colliding black holes, but in order to do that accurately, we need to make sure our instruments are tuned in, and that's where calibration comes in.
When gravitational wave comes, the two arms of the detectors moves that way, and then you measure the interference pattern. But that's actually not what happened. The detectors need to operate in a perfect state, and we need to keep the arm lengths almost unchanged. And then we recover everything to measure the signal in the detector. That is called calibration.
Well, normally we would do this calibration process with a bunch of extra information from sensors, other lasers, but what do you do when you don't have this information? Well, that's when we can actually use the signal itself.
And that's exactly what these three Ozgrad women helped achieve with two separate black hole collisions.
GW240925 is a small and light event where we have two black holes around 10 times the mass of the Sun merging into one another. And then the second event, GW250207, is a slightly larger event where we have two black holes around 30 times the mass of the Sun merging into each other. This is very similar to the very first black hole merger that we've detected, except it's about 3 times louder, and it's the second loudest black hole binary event we've ever detected.
This concept of astrophysical calibration, where the signal is used to calibrate the detector, was first tested with the first event, GW240925, but then the technique was applied for real with the loud event, GW250207. We're able to do this now because the detectors are so much more sensitive thanks to significant upgrades over the past decade.
So astrophysical calibration is really important because we want to do as much science as we can from these signals. And what happens if we get unlucky? This really, really cool, interesting signal just happens at this wonky time, and we can't do anything with it. We just have to check it out. Well, with astrophysical calibration, we don't need to do that. We can use the signal itself.
With the help of astrophysical calibration, on the very rare occasions where it's needed, we can combine more data from more detectors, which gives us a lot more information to work with.
So with 2 detectors, we actually managed to narrow down the location of this binary black hole merger to a shape of banana in the sky. But with 3 detectors, with the astrophysical calibration, we're actually more confident that it's in this scrape here.
And with more accuracy like that, scientists are able to understand more about the universe, from the nature of black holes to the expansion of the universe itself.